experiment out of 5. Well done for making it this far. And this one is metal extraction. So remember, this is the process where we are extracting metals from their ores, and their ores are profitable rocks that we find with enough metal to get out of. Alright, we don't have to spend too much money to get enough out, and we make a profit on them. And they're always oxides. We have a copper oxide, we have a magnesium oxide, and we have an iron oxide. Alright, again, really important in this experiment is your reactivity series. Learn it, ladies and gentlemen, it will help you. Make a mnemonic thing. Alright, just make sure you know that for this, so that when you go into a chemistry exam, you can scribble it down and then get on with your work. Okay? So what we have is also charcoal, or coke, or as you guys like to call it. Alright, we have charcoal, and we're going to be mixing that with our oxides in our crucible, and then we are going to be heating them at high temperatures to see if a reaction has taken place. Okay, some of these metals will be extracted and some of them will not. The key, as always, is your reactivity series. You need to learn which ones are extracted by smelting, which ones are extracted by electrolysis. Okay? Right, should we start? So first of all, we have some of the charcoal. Some of that coke goes in there. Let's put 2 spatulas full. Okay, and we will use magnesium oxide. What do you expect to happen? Think about it as I'm doing this. Remember, magnesium is pretty high on the reactivity series. Is it higher or lower than carbon? Will the magnesium oxide be reduced, losing its oxygen, and just turn into that magnesium that we so desire? Okay, so that we can burn it for you guys to burn your eyes out. Right, so let's heat this thing up. Pop it on the crucible. Oh, I don't have any tongs. Hold on. 2 seconds. My tongs. So remember, these are hot apparatus. We do safety first. And we pop it on our crucible. Okay, and leave it to heat for a while. What do you expect to happen? Are you expecting magnesium to be reduced by carbon? Is it higher up than carbon on the reactivity series? What do you think? Okay. As you can see, there is a reaction. There is gas being produced there. But is it enough? Is that enough to show us? How do we know if a reaction is taking place? How will we know if a metal has been formed? Okay, if a metal oxide has been reduced and carbon has been oxidized. Please remember, reduction is the loss of oxygen, oxidation is the gain of oxygen. Any question where they ask you this, the first thing you should write is that sentence. Reduction is the loss of oxygen and oxidation is the gain of oxygen. And then answer the question. You lose marks by not mentioning that sentence, and I know you all know it. Alright, so we've left that on there for a while. It's certainly heating up. And I think we could probably take it off. Alright? I don't know where I'm going to put it though. So it's nice and hot. You can see that it's glowing hot at the bottom. You know that you've probably got it to the right temperature for something to happen if magnesium is lower on the reactivity series than carbon. Remember, nothing will happen unless carbon can take that oxygen away from the oxide, okay? From the ore. Don't forget the word ore, please. Spelled O-R-E, not A-W-E. Okay? Right. So whilst we're looking at that, we're going to wait for that to cool down slightly. I don't know if it's going to burn this paper. Okay, and maybe slightly foolishly, I've put it onto that piece of paper. You can see magnesium oxide and charcoal are the same as they were in the beginning. There has been no reaction. And this is because, as I'm sure you rightly thought, magnesium is not reduced by carbon, okay? That is why magnesium oxide must be, the metal must be extracted from magnesium oxide by a different process. Can you name that process? Make sure you can, please. Right, copper oxide. What are you expecting with copper oxide, ladies and gentlemen? Do you expect the same thing to happen again? I'm not going to show you what's going to happen. I want you to look at your reactivity series and predict, okay? Iron oxide. Now, this is the one that you really, this is a nice red colour. Remember, iron oxide is a red colour, hematite. Yes. And look at your reactivity series again. You should have it in front of you. What do you expect to happen? Popping our iron oxide in to the crucible, and our reducing agent, our charcoal or coke. Okay. Now, this is a very similar process to the blast furnace that you all know about. So you should really have a really good idea already of what is going to happen. So there we are, we pop it on. And we heat it to a high temperature, probably not high enough really, but we will see how we go.